Hello and welcome to PreCalc Honors. I'm going to be flipping the classroom this year, which means that you're going to take the notes from my video and then we'll do some exercises in class the next day. So we're going to start with chapter 1.1 from your textbook. This chapter is called Functions and Their Graphs. And the first thing we're going to talk about is parent functions. Hopefully you've talked about parent functions before in your previous math courses. And a parent function is just a set of basic functions that are used as building blocks for more complicated functions. And they're the simplest function in a family of functions. There are several different types of parent functions, and the first one we're going to look at is something called the constant function. The constant function is just f of x is equal to c. C stands for constant. It's any real number. For example, and you know that f of x is the same thing as y, so you can either say f of x is equal to a number or y equals a number. We'll call it f of x. Let's say f of x is equal to 4.5. That's a constant function. Now the graph of a constant function is just a horizontal line. So when we take a look at these graphs or these different parent functions, we'll just look at a graph also of it. So here's a set of x-y axes here, and 1, 2, 3, 4, 5 x and y. And if this is y equals 4.5, you go up to 1, 2, 3, 4.5. And the y-intercept is 4.5, and you can just draw a little horizontal line here. This is f of x is equal to 4.5. The second type of parent function we're going to talk about is a linear function. You studied linear functions since Algebra 1. Linear functions come in three forms. And its graph is a diagonal or slanted line. Linear, the root word of linear is line. So the first form you'll see is called slope-intercept form. This is the most common one that you worked with in Algebra 1. This is y equals mx plus b. It's called slope-intercept because m is the slope, b is the y-intercept, and they're always filled in as any numbers. So for example, y is equal to 3x minus 2 would be a linear function in slope-intercept form, or f of x is equal to 3x minus 2. So the slope is 3. The y-intercept is equal to negative 2. And it's pretty simple to graph. You go down to the y-intercept of negative 2. You put a point on the graph, and if the slope is 3, that means up 3 and over 1. So the second point on the graph would be right here at 1, 1, and then you can just connect those 2 points, and there's your y equals 3x minus 2 graph. The second form is called standard form. So here's slope-intercept, standard form. And standard form is ax plus by is equal to c. A, b, and c are any real numbers. So for example, if you have something like 3x plus 5y is equal to 15, that's a linear function in standard form. And to graph that, you can find the x and y intercept. So find the x-intercept by setting y equals 0. Hopefully this is a review of what you've done before. So let's find the x-intercept. Let's set y equal to 0. So we have 3x plus 0 is equal to 15. So that means x is equal to 5, which means 5, 0 is the x-intercept. Now you're going to find the y-intercept by setting x equal to 0 and solving for y. So if x is equal to 0 up here, it's just 0 plus 5y, or in other words, 5y equals 15, so y equals 3. So in other words, 0, 3 is the y-intercept. So we found the x-intercept, we found the y-intercept. So now in order to graph those, we can just plot those 2 points and draw a straight line between them. So the x-intercept of 5, 0, 1, 2, 3, 4, 5, 0, and the y-intercept of 0, 3, 1, 2, 3. We got 2 points, and 2 points define a line or a linear function, and there is your graph of 3x plus 5y equals 15, and any point along this graph would satisfy that equation. The third form of a linear function is called point-slope form. This is the most important form in calculus that we're going to be using, so you're going to have to be really familiar with that. The point-slope form goes like this. Y minus y1 is equal to m times x minus x1. M, again, is the slope. And x1, y1 is any point on the graph. Any point at all. So what we're going to do is we're going to write a linear function in point-slope form as our example. Let's write a linear function in point-slope form passing through these points. THROUGH, passing through -1, 4, and 9, 5. All right, so we have 2 given points. What we need to do is calculate the slope with the slope formula and then use one of those 2 points and plug it into the point-slope form. So first, finds the slope. And if you remember the slope formula, y1 minus y2 divided by x1 minus x2, or in other words, rise over run. Well, these points we can define our x's and y's. So let's call this -1, 4. We'll call this x1, y1, and we'll call 9, 5, x2, y2. We'll just name those. So if you wanted to find the slope using these x and y values, the slope is equal to y1, which is 4, minus y2, which is negative 5, 4 minus negative 5, all over x1, which is negative 1, minus x2, which is 9. 4 minus negative 5 is 4 plus 5, which is 9, and negative 1, oh, I'm sorry, I didn't want to use, I wanted to use 8, because this isn't working out really well. So if you can please change this 9 comma 5, can you just move this or change this into an 8 negative 5, and down here negative 1 minus 8, that'll give us a better slope, because negative 1 minus 8 is negative 9, and 9 over negative 9 is equal to negative 1. Sorry about that little slip up there. So we found the slope, and then you can use either point and plug it in. So that's your first job. First, find the slope, and second, use either point in formula, which is this formula up here. So let's use this x1, y1 here. So we have y minus y1, which is 4, is equal to m, which is the slope, negative 1, times x minus x1, which is negative 1, minus a negative 1. So we can just call that y minus 4 is equal to negative, you don't have to write the 1 on the outside of the parentheses, so negative x minus a negative is plus 1. So there, whoops, y minus 4, sorry, I'm making a couple mistakes here. Y minus 4 is equal to negative x plus 1. And you can always add 4 to both sides if you wanted to put it in your graphing calculator, y equals negative x plus 1 plus 4 if you want, but that's not necessary. You can just leave this here. Let me rewrite this so it looks better. Y minus 4 equals negative x plus 1. So there's your point slope form. And if you wanted to graph this, it's pretty easy. You can just plot negative 1, 4 and 8, negative 5, and then just connect those 2 points together. So negative 1, 4, negative 1, 1, 2, 3, 4, and 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. So there are the 2 points for the graph of this linear function. Now just a couple other things to wrap this up. Hopefully you remember that parallel lines have equal slopes. And perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. For example, y equals 4x plus 5 and y equals 4x minus 2. Those two are parallel. Those two are parallel because the slopes are 4 and they're equal to each other. They just have different y-intercepts. And the other one, a perpendicular example, y equals 3x minus 8, y equals negative 1 over 3x minus 2. Those are perpendicular because the slopes 3 and negative 1/3 are negative reciprocals. Horizontal lines have a slope of 0. Vertical lines, or I'll give you an example of this. Example, y is equal to 6 That's a horizontal line. That's also called a constant function. And you can remember from the other page that that graph was a horizontal line, and a vertical line has undefined slopes. For example, x is equal to 7. This is not a function because it fails the vertical line test. So it's not even a function. It fails the vertical line test. If you remember that, hopefully. So vertical lines are up and down. Oops. Horizontal lines are like the horizon. Horizontal lines go like this. And that's about it for today. Have a great one. See you tomorrow.